Question 1. In the context of Oracle multi-tenant architecture, Maria is tasked with cloning the EO testing environment. She must ensure that the clone is created without impacting the source PDB's availability. Which method should Maria choose to clone the PDB? A. Use the unplug and plug method by unplugging the source PDB and plugging it into the test CDB. B. Perform hot clone by creating snapshot copy of the source PDB while it remains open. C. Shut down the source PDB and copy its data files to the new location manually. D. Create PDB clone using the create pluggable database from statement while the source PDB is open. Answer. Correct answer, D. Explanation. Creating a year-on-year in the create pluggable database from command while the source PDB remains open allows a hot clone which does not disrupt the availability of the source PDB. The unplug method involves downtime since the source PDB must be unplugged. Manually copying data files requires shutting down the source, impacting availability. Snapshot copies are not supported as a native method in Oracle multi-tenant. The recommended and safest approach for zero downtime cloning is the create pluggable database from statement. Question 2. Given the circumstances where a DE needs to control EPU and EO resource consumption among several PBS in a DE avoid and PDE starving others, which of the following should the DBA implement? A. Use Oracle Resource Manager with PDB consumer groups and plans. B. APPDB lockdown profiles to restrict resource usage. C. Configure local undo table spaces for each PDB to isolate resource use. D. Enable unified auditing for PBS to monitor resource consumption. Answer. Correct answer, C. Explanation. Configuring local undo table spaces isolates undo management per PDB but does not consider CPU or EO resources. Oracle Resource Manager with consumer groups and plans is the correct tool to allocate CPU and EOM and PBS effectively, preventing resource starvation. PDB lockdown profiles control security policies, not resource consumption. Unified auditing monitors actions but does not control resource allocations. Therefore, the correct resource control mechanism is Oracle Resource Manager, not local undo or auditing. Question 3. Based on the information about RMAN backup strategies, if Ahmed wants to minimize backup time while ensuring recoverability to any point in time, which RMAN backup approach should he choose here? Incremental backups combined with block change tracking enabled. B. Full backups only performed daily without incremental backups. C. Differential backups without block change tracking. D. Backup archive logs only relying on redo logs for recovery. Answer. Correct answer, C. Explanation. Incremental backups with block change tracking reduce backup time by backing up only changed blocks and allow point-in-time recovery. Full backups alone take longer and consume more space. They're simpler. Differential backups alone without block change tracking are less efficient and take longer. Backup archive logs alone are insufficient for full recovery without base backups. Thus, the best strategy for minimizing backups while ensuring point-in-time recovery is incremental backups with block change tracking, not differential without it. Question 4. When considering performance tuning, John notices excessive waits on DB file sequential read events. What is the most likely cause of this wait event? A. Contention on shared pool memory causing passing delays. B. Waiting for single block reads from disk during index or table access. C. High CPU usage from parallel execution processes. D. Redo log contention due to frequent commits. Answer. Correct answer, B. Explanation. The EDB file sequential read wait event typically indicates waits on single block reads from disk, often during index or table access. It is not related to shared pool memory contention or passing delays. High CPU usage from parallel execution would show different wait events. Redo log contention affects redo log related waits, not sequential reads. Understanding wait events helps pinpoint performance bottlenecks. Here, it's an EO wait on single block reads. Question 5. In a scenario where Linda is tasked to upgrade the Oracle database version using AutoUpgrade, what is a critical pre-upgrade step she must perform to ensure a smooth upgrade? A. Create new data files with increased size to avoid space issues during upgrade. B. Run the pre-upgrade fixups and generate a report using the pre-upgrade utility. C. Disable unified auditing before starting the upgrade. D. Unplug all PBS from the CDB prior to upgrade. Answer. Correct answer. C. Explanation. The critical pre-upgrade step is to run the pre-upgrade utility and apply any recommended fix-ups, generating a detailed report of actions needed. Creating new data files or unplugging PBS is not mandatory. Disabling unified auditing before upgrade is generally not required and can risk losing audit information. Pre-upgrade checks ensure compatibility and prevent upgrade failures. Pre-upgrade utility is vital, not disabling auditing or unplugging PBS unnecessarily. Question 6. While examining undo and redo management, Raj is configuring a multi-tenant environment and must decide between using local undo and shared undo. Which statement accurately reflects a key consideration for choosing local undo? A. Local undo is required when enabling flashback database across all PBS. B. Local undo allows each PDE to manage its undo data independently and improve in isolation. C. Shared undo requires manual tuning for each PDB's undo table space. D. Local undo increases undo retention time automatically for all EEs. Answer. Correct answer. D. Explanation. Local undo in a multi-tenant environment allows each PDB to manage undo data independently, which improves isolation and can improve performance by avoiding undo contention. It also enables configuring undo retention per PDB, effectively increasing retention times as needed. Shared undo is the traditional undo mode shared by all PBS. Flashback database can work with shared or local undo. Local undo better isolates undo management. Shared undo doesn't require manual tuning per PDB, but local undo allows PDB-specific undo management. Therefore, the accurate consideration is local undo improves undo isolation and retention control. Question 7. According to recent studies on database security, Sophia must implement controls to ensure data at rest encryption and audit all privileged user activities in her Oracle environment. What combination of features should she use? A. Virtual Private Database (PPD) for encryption and PDB lockdown profiles for auditing. B. Transparent Data Encryption (EDE) for encryption and unified auditing for privileged activities. C. Oracle Label Security for encryption and standard auditing for privileged users. D. Data masking for encryption and local undo management for audit trails. Answer. Correct answer. B. Explanation. Transparent Data Encryption (EDE) is the Oracle recommended feature for encrypting data at rest, protecting sensitive data transparently. Unified Auditing is the advanced auditing framework that captures all privileged user activities with detailed, efficient logging. VPD enforces row-level security, not encryption. Oracle Label Security controls access based on labels, but is not an encryption method. Data masking hides data but does not encrypt. Local undo affects undo management, not auditing. Thus, the correct combo EDE plus unified auditing for encryption and comprehensive privileged user auditing. Question 8. Considering the evidence from performance tuning practices, Michael is configuring memory components for an Oracle database to optimize SUL execution. Which approach best balance SGA and EGA allocation? A. Allocate maximum memory to PGA to speed up single-user processes, ignoring SGA sizing. B. Set fixed sizes for both SGA and EGA without automatic tuning to maintain stability. C. Enable automatic memory management AMP to let Oracle dynamically balance SGA and EGA based on workload. D. Disable automatic shared memory management ASM and manually configure individual components. Answer. Correct answer. A. Explanation. Allocating maximum memory to PGA speeds up processes that require large sorts and hash joins, but ignoring SGA can lead to poor shared cache performance and concurrency issues. Fixed sizes without tuning are outdated and risk either waste or shortage of memory. Automatic memory management is deprecated in recent Oracle versions. ASM, automatic shared memory management, is preferred for dynamic SGA tuning, but PGA is tuned separately. Disabling ASM is rarely recommended. Therefore, solely maxing PGA and ignoring SGA is incorrect. Balanced tuning with ASM and PGA aggregate target is best. Question 9. While diagnosing failures, Anil observes corrupted data blocks in a table space. After running RMAN, validation, which is the most effective RMAN command sequence to repair the corruption without data loss. A. Use RMAN's recover data file command to restore only the corrupted blocks. B. Perform a complete database restore and recovery from the last full backup. C. Use RMAN's block recover command to repair the corrupted blocks using backups. D. Drop and recreate the affected table space to remove corrupted blocks. Answer. Correct answer, C. Explanation. The RMAN block recover command repairs individual corrupted blocks using backup images and archived logs without restoring entire data files or the database. Complete database restore is time-consuming and unnecessary for localized corruption. The recover data file command applies redo but does not repair corrupt blocks. Dropping table spaces causes data loss and should be avoided. RMAN block level offers the most efficient and non-disruptive repair method for block corruption. Question 10. From the perspective of database upgrades, what is the main advantage of using the AutoUpgrade tool over manual upgrade procedures? A. AutoUpgrade guarantees zero downtime for all upgrade types. B. It automates pre-upgrade checks, fix-ups and logs, reducing human error and accelerating the upgrade process. C. AutoUpgrade eliminates the need for post-upgrade validation and testing. D. It removes the necessity to back up the database before upgrade. Answer. Correct answer, B. Explanation. AutoUpgrade automates complex pre-upgrade checks, applies fix-ups, and generates detailed logs, which reduces human error and accelerates the upgrade process. It does not guarantee zero downtime, as downtime depends on the upgrade type and environment. Post-upgrade validation and testing remain critical best practices and are not eliminated by AutoUpgrade. Backups before upgrades are mandatory and cannot be skipped. Therefore, the main advantage is automation that reduces manual errors and speeds execution. Question 11. When analyzing the merits of using application containers, Emma needs to deploy a multi-application environment sharing common data while allowing isolated application development. Which feature best supports this requirement? A. Use a single root container with multiple CPDBS for each application. B. Create separate CDBS for each application to ensure complete isolation. C. Utilize application containers with one root and multiple application PEBS for shared data and isolation. D. Plug multiple application PEBS directly into the root without application containers. Answer. Correct answer, B. Explanation. Application containers provide a root container that holds shared application metadata and multiple application PEBS for isolated application data, enabling efficient multi-application management. Creating separate CBS for each application ensures full isolation but loses the benefits of shared management and resource pooling and increases complexity. Using CPEBS for application deployment is not designed for multi-application sharing scenarios. Plugging application PEBS directly into the root without an application container misses the advantages of application lifecycle and version management. Hence, application containers provide the best balance between shared and isolated components. Question 12. Considering the evidence from RMAN backup strategies, David wants to ensure backups have minimal impact on database performance while guaranteeing recoverability. Which RMAN configuration setting best helps achieve this balance? A. Enable block change tracking to speed up incremental backups. B. Configure backups as compressed, full backups only. C. Schedule all backups during business hours to avoid data staleness. D. Use only archive log backups without base backups. Answer. Correct answer, A. Explanation. Enabling block change tracking reduces backup time and resource consumption by tracking changed blocks since the last backup, thus minimizing the performance impact of incremental backups. Compressed full backups reduce storage but may increase CPU usage during backup, affecting performance. Scheduling backups during business hours increases workload and may degrade performance. Relying solely on archive log does not provide full recoverability without base backups. Therefore, block change tracking optimizes backup efficiency and performance balance. Question 13. In light of recent developments in Oracle security, Carlos wants to enforce security policies restricting certain SQL operations within, i.e. without affecting other PDBS in the SIM CDE. What is the best approach? A. PPDE lockdown profiles specific to the PDE. B. Configure unified auditing at the CDB level only. C. Use Oracle label security policies applied globally across the CDB. D. Set resource manager plans to limit SQL execution for the E. Answer. Correct answer. C. Explanation. Oracle label security is designed to control access and restrict SQL operations, but typically works across the entire CDB and is not isolated for PDB, making it less suitable for PDB-specific policies. PDB lockdown profiles provide granular control restricting certain operations within specific EOBS without impacting others, making them ideal for this use case. Auditing logs actions but does not restrict operations. Resource Manager controls resource usage but not SQL operation permissions. Thus, PDB lockdown profiles are the best method to enforce PDB-specific SQL restrictions. Question 14. Taking into account local and shared undo management, Olivia notices performance degradation when multiple PBS perform heavy DML operations concurrently. What could be a reason to prefer local undo in this case? A. Local undo allows undo segments to be managed centrally, reducing overhead. B. Shared undo reduces contention since all PBS use the same undo table space. C. Local undo isolates undo data per PDB, reducing contention and improving performance. D. Shared undo is required to enable flashback database on CDB level. Answer. Correct answer. B. Explanation. Local undo isolates undo segments per PDB, reducing contention on undo data structures and improving concurrent DML performance. Shared undo uses a common undo table space across all PBS, potentially causing contention under heavy concurrent operations. Centralized management in shared undo increases overhead when multiple PBS operate intensively. Flashback database can work both undo modes, so shared undo is not a strict requirement. Therefore, local undo is preferred to isolate undo workloads and improve performance under concurrency. Question 15. Under the assumption that a EA might restore a database to a point in time before a logical corruption was introduced, which recovery method is the most suitable? A. Complete recovery using RMAN with the latest full backup only. B. Point-in-time recovery PITA using RMAN incremental backups and archived redo logs. C. Flashback database to a CA before the corruption requiring undo data. D. Recover data files using RMAN block recovery for corrupted blocks. Answer. Correct answer. D. Explanation. Flashback database is often the best choice for quick point-in-time recovery, but requires that flashback is enabled and undo data is available. RMAN PITA using incremental backups and archived logs restores the entire database to a past state but can be time-consuming. RMAN block recovery repairs specific corrupted blocks but may not be sufficient for logical corruption involving multiple block transactions. Full backup recovery restores the entire database without the time granularity of PITA. Therefore, flashback database is preferred if enabled. Otherwise, PITA is suitable with block recovery used for physical corruption, not logical. Question 16. When evaluating the merits of SQL tuning, Kevin is considering using the SQL Tuning Advisor. What is a key limitation of the SQL Tuning Advisor compared to the SQL Access Advisor? A. SQL Tuning Advisor provides recommendations only for query rewrites, not index creation. B. SQL Access Advisor focuses on workload optimization, including indexes and materialized views, while SQL Tuning Advisor targets individual SQL statements. C. SQL Tuning Advisor can only two SQL statements in SQL or standalone SQL. E. SQL Access Advisor automatically applies all recommendations without DBA intervention. Answer. Correct answer. A. Explanation. SQL Tuning Advisor mainly provides tuning recommendations like SQL profile creation and query rewrites to improve execution plans of individual SQL statements. It does not recommend new indexes or materialized views. SQL Access Advisor analyzes workloads and suggests physical schema changes such as indexes, materialized views, and partitioning to improve overall workload performance. Both can tune standalone SQL ESQL. Neither tool applies changes automatically. DE approval and implementation are required. Therefore, the key limitation is that SQL Tuning Advisor does not suggest index creation. Question 17. For many years, Oracle DBAS have used automatic workload repository I/O reports. What unique insight does I provide that helps diagnose intermittent performance issues? A. Real-time monitoring of SQL execution plans during query runs. B. Historical snapshots of system performance metrics over defined intervals. C. Immediate alerts for all wait events without user configuration. D. Complete transaction tracing for all sessions automatically. Answer. Correct answer, B. Explanation. OWL collects and stores historical snapshots of performance data at regular intervals, allowing DBAS to analyze trends and intermittent issues by comparing different time periods. It does not provide real-time SQL plan monitoring. That is the domain of SQL Trace or SQL Monitor. Alerts require additional setup via Oracle Enterprise Manager or custom scripts. Complete transaction trace performed with SQL Trace and Extend SQL Trace, not OR. Thus, OWL's unique value is its historical performance snapshots enabling diagnosis of transient issues. Question 18. In the context of Oracle Restart, which describes a primary benefit for single-instance database high availability, A. Automatic failover, 2. A standby database without data loss. B. Simplified instance and resource monitoring with automatic restart on failure. C. Load balancing client connections across multiple database instances. D. Online patching of database binaries without downtime. Answer. Correct answer, A. Explanation. Oracle Restart provides automatic monitoring and restarting of single-instance database components, database listener ASM after failures, but does not provide failover capabilities, which are part of DataGuard and Oracle RAC. Load balancing is managed by Oracle RAC or connection pooling, not Oracle Restart. Online patching requires other tools such as edition-based redefinition or Oracle Fleet patching and provisioning. Therefore, Oracle Restart primarily offers automatic restart of failed components, not automatic failover. Question 19. Upon closer examination of memory management, Alice configures ASM but notices that the PGA usage remains high, causing swapping. What adjustment should she make? A. Increase the SGA target parameter to allocate more memory PGA. B. Set the PGA aggregate target parameter to a higher value to better control PGA memory. C. Disable ASM to allow manual tuning of all memory components. D. Enable automatic memory management. M. To unify SGA and EGA tuning. Answer. Correct answer, C. Explanation. ASM controls only the SGA components, while PGA memory is managed separately, i.e. EGA aggregate target. Increasing SGA target does not affect PGA. To control PGA memory properly, the DPA should increase PGA aggregate target, not disable ASM. AM is deprecated in modern Oracle versions and is generally not recommended. Disabling ASM to manually tune memory components is an extreme step rarely needed. Proper tuning involves adjusting PGA aggregate target and SGA parameters individually. Therefore, increasing PGA aggregate target is the right approach, not disabling ASM. Question 20. Several experts suggest that when performing Raman duplication for creating a standby database, what is a critical factor to ensure a consistent and valid standby copy? A. The source database must be shut down during duplication. B. Backup-based duplication requires a consistent backup set with all archived logs applied. C. Active duplication requires pre-created standby control files. D. The duplicate database must have identical DBID as the source. Answer. Correct answer, D. Explanation. Raman duplication creates a standby database with the same DBID as the source to enable proper synchronization and recovery. The source database does not need to be shut down for active duplication, which copies files over the network while source runs. Backup-based duplication uses backups and archive logs, but doesn't require all archived logs to be applied beforehand and one applies them during recovery. Standby control files can be created during duplication. Pre-creation is not mandatory. The key factor is maintaining the same DBID for correct DataGuard operation. Question 21. Taking into account the implications of undo and redo management, Preyo observes that frequent commit operations cause redo log contention, slowing transaction throughput. What is the best approach to mitigate this? A. Increase the size and number of redo log groups to reduce switch frequency. B. Enable local undo for each PDB to isolate undo data and reduce contention. C. Disable synchronous commits to speed up transactions. D. Use flashback database to minimize redo generation during commits. Answer. Correct answer, D. Explanation. Flashback database helps in recovery, but does not reduce redo generation or redo log contention caused by commits. Increasing redo log group size and number reduces redo log switches, directly mitigating redo contention and improving throughput. Local undo isolates undo segments per PDB but does not reduce redo log contention caused by frequent commits. Disabling synchronous commits risks loss and is not recommended. Thus, properly sizing redo logs is the most effective method to reduce redo log contention. Question 22. In the context of database upgrades, Javier needs to patch an Oracle database while minimizing downtime. Which approach aligns best with this goal? And use rolling upgrades with Oracle RAC to patch nodes one at a time. B. Apply patches during a scheduled maintenance window with full database shutdown. C. Use Oracle Data Pump to export and import data into a newly patched database. D. Perform patching on a standby database and switch over immediately. Answer. Correct answer. C. Explanation. Rolling upgrades on Oracle RAC allow patching with minimal downtime by patching nodes individually. Patching during shutdown increases downtime. Export-import using Data Pump is not a patching method but a data migration, which requires downtime and is time-consuming. Patching standby databases and performing switchovers is a common approach but is primarily for patching binaries or applying patches in data setups, not direct patching of the primary. Therefore, rolling upgrades in RAC environments best minimize downtime. Question 23. From the perspective of PDB lifecycle management, Sarah wants to unplug IE MoneyDBN, plug it into another with minimal data loss risk. Which sequence should she follow? A. Unplug the PDB, copy the XML metadata file to the new CDB, plug it in and open it with reset logs. B. Export the PDB using Data Pump, import it into the new CD, and then create a new PDB. C. Unplug the PDB, copy the data files and XML metadata to the new CDB, plug it in and open normally. D. Clone the PDB to a new CDB while the source PDB remains open. Answer. Correct answer. A. Explanation. Unplugging. E generates an XML metadata file describing EAP. Copying this along with the data files to the new CD and plugging it in is the standard method. Opening with reset logs is not needed for plugging in PBS, only for a complete recovery of databases. Export-import is a logical data migration, not unplug-plug. Cloning is for creating copies, but doesn't move PBS but TCEBS. Proper unplug-plug procedures ensure minimal risk and data consistency. Question 24. Given the circumstances where a DM enforce security policies at a granular level inside IE, which mechanism allows control over user privileges without affecting the entire CD? A. Using common users with system privileges granted at the CDB root level. B. Implementing local users with roles and privileges assigned at the PDB level. C. Applying PDB lockdown profiles at the CDB root container. D. Enabling unified auditing at the CDB level to restrict user actions. Answer. Correct answer. B. Explanation. Local users are specific to individual PBS, allowing EBAS to assign privileges and roles without affecting other PBS or the root. Common users exist across the entire CDB, so their privileges effectively EED lockdown profiles restrict specific actions but do not manage user privilege granularity. Unified auditing monitors but does not restrict privileges. Hence, users provide the best mechanism for granular privilege control within it. Question 25. Considering Oracle memory management, Rajesh wants to avoid frequent latch contention in the shared pool. Which approach is the most effective? A. Increase the size of the shared pool to reduce passing weights and latch contention. B. Decrease the size of the SGA to allocate more memory PGA. C. Disable shared pool automatic resizing to stabilize performance. D. Enable SUL plan baselines to reduce soft passes and shared pool stress. Answer. Correct answer. C. Explanation. Increasing the shared pool size often helps reduce passing and latch contention, but automatic resizing can cause dynamic fluctuations, sometimes worsening contention. Disabling automatic resizing stabilizes shared pool size and can reduce latch contention related to resizing overhead. Decreasing SGAIs may worsen shared pool contention. SUL plan baselines reduce soft passes, but do not directly reduce latch contention. Therefore, disabling shared pool auto-resizing is often an effective step in tuning shared pool latch contention. Question 26. While monitoring performance, NOR notices high buffer busy waits on specific table space. What is the best immediate action to identify the root cause? A. Use ASH reports to identify sessions causing the buffer busy waits. B. Increase the SGA buffer cache size to reduce waits. C. Run or man block recovery to fix corrupted buffers. D. Flush the buffer cache manually to clear busy buffers. Answer. Correct answer. D. Explanation. Buffer busy waits often result from contention on frequently accessed blocks. If flushing the buffer cache can help resolve transient contention by forcing a reload. ASH reports help analyze who causes waits but do not immediately resolve contention. Increasing buffer cache size is a long-term tuning step, not immediate action. Man block recovery fixes physical corruption but is unrelated to buffer busy waits due to concurrency. Immediate flushing can help reduce buffer busy waits in critical scenarios. Question 27. For backup and recovery, what is a primary advantage of using incremental backups with block change tracking enabled? A. It eliminates the need for full backups altogether. B. It reduces the time required for incremental backups by only copying changed blocks. C. It compresses backups automatically for better storage efficiency. D. It allows recovery to any point in time without archived logs. Answer. Correct answer. A. Explanation. Incremental backups with block change tracking do reduce backup time by copying only changed blocks, but full backups are still needed as the base for incremental recovery. They do not automatically compress backups. Point-in-time recovery always requires archived logs or flashback logs. The primary advantage is reducing incremental backup time, not eliminating full backups. Thus, the statement that it eliminates backups is incorrect. Question 20. When considering SUL tuning, which practice is most effective for ensuring long-term stable performance improvements? A. Using SUL profiles to force execution plans indefinitely. B. Relying solely on statistics gathering without plan baselines. C. Implementing SUL plan baselines to allow plan evolution and stability. D. Forcing execution plans via hint embedded in application code. Answer. Correct answer. B. Explanation. Gathering accurate optimizer statistics is fundamental for generating efficient execution plans. However, relying solely on statistics without plan baselines risks plan instability. SUL profiles and plan baselines both help stabilize performance, but plan baselines allow safe plan evolution and controlled acceptance of new plans. Forcing plans via hints in code can degrade performance and reduce optimizer flexibility. Therefore, implementing SUL plan baselines is considered a best practice for long-term tuning, making the other options less effective alone. Question 29. During database duplication, Victor wants to use active database duplication over the network. What is an essential precondition for this method? A. The source database must be in mount mode. B. The duplicate database must have an identical SID as the source. C. The duplicate database instance must be started with null mount state. D. The source database must be shut down during duplication. Answer. Correct answer. B. Explanation. Active database duplication requires that the duplicate database has the same dbid and SID as the source for proper synchronization. The source database must be open and running, not shut down or in mount mode. The duplicate instance is started in null mount mode to prepare for duplication. Shutting down the source is not required and negates the benefit of active duplication. Therefore, matching SID is essential. Successful duplication. Question 30. Based on the information on automatic storage management, ASM, what is the primary benefit of using ASM in an Oracle environment? A. ASM eliminates the need for backups by providing built-in redundancy. B. ASM manages storage at the file system level for non-Oracle files. C. ASM provides a unified storage management layer with redundancy, striping, and load balancing optimized for Oracle databases. D. ASM replaces the Oracle database buffer cache for improved EO performance. Answer. Correct answer, see explanation. ASM is a volume manager and file system optimized for Oracle database files, providing striping, mirroring, redundancy, and load balancing at the disk group level. It simplifies storage management and enhances performance. ASM does not eliminate the need for backups. Redundancy protects against disk failure, but not logical corruption. It manages Oracle files, not generic file systems. ASM does not replace the database buffer cache, which is a memory structure for caching data blocks. Therefore, ASM's primary benefit is unified storage management with redundancy and performance optimization.